and I'm going to discuss how to assess the sensitivity of a network. One common mistake students make is that they assume when we use the term sensitivity, we are referring to the likelihood that the project will take longer than planned. In reality, we use the term sensitivity to reflect the likelihood that the original critical path will change. To assess sensitivity, the first question you ask is, do we have more than one critical path? If we have more than one critical path, then that increases the likelihood that one of those paths, if it takes longer than planned, will make the other paths non-critical. We look at this network and we see we only have one dominant path, which suggests low sensitivity. Then the second question is, what about the non-critical activities? What's the likelihood if they take longer than planned or start later than planned, they will become critical? And to assess that, we look at how much slack they have. And to do that, we go up to Table and look at Schedule. And we look at the Schedule table. We'll scroll over here since we don't really need the Gantt chart right now. And one of the things you'll notice is that we have two columns, free slack and total slack. And if you go down these columns, all the red critical activities have zeros, while the blue activities, and there's one of them right there, has 7 days of slack. So the three non-critical activities have slack. Also notice that purchase hardware components has no free slack, while assembling hardware components does. Why is that the case? Well, in reality, those two activities are linked and therefore share the slack. And we scroll this out, we can see this. Here's the 7 days of slack. And if there's a delay in the start of purchasing hardware components, or if that takes longer than a day, then some of that slack would be used up and the assembly hardware start would be delayed. Free slack is given to the last activity in a chain that feeds into a critical path. Or another way of looking at this is free slack is the amount of time that a task can be delayed without delaying successor tasks, and total slack is the amount of time that a task can be delayed without delaying the project. So when we look at the amount of slack that the non-critical activities have compared to how long we've estimated their tasks will take, we would argue that this is not a very sensitive network. Remember, programming code B is estimated to take 3 days, and we've got 2 days of slack, over 60%. Likewise, purchase and assembly hardware each are supposed to take 1 day, and in this case we have 7 days. So, given this information, all other things being equal, we would argue that this is not a very sensitive network, that the chances are low that the original critical path will change once the project is underway.